So do I need to do? Okay, okay, okay. As I used to do it like this. So, and in this session, we will introduce the how to deploy MPLS Layer 3 VPN, and there would be 3 parts. Later, I will explain. And at the beginning, I would like to introduce myself. My name is Jessica. I'm a training officer from APRICOT. Before I joined the APRICOT in 2015, I was working in Huawei as a training officer, and for nearly 6 years in Huawei and doing the datacom trainings. And later, my manager Nuru will also join me and to do some demo and the second part of the tutorial. So the whole contents are here. The whole contents are here. So for the first part, I would introduce what is the Layer 3 VPN, the basic parts, the basic principle of Layer 3 VPN, because there are some terminologies related to Layer 3 VPN, what are RD, RT, and about the control plane, data plane. Because for some new learners for the Layer 3 VPN, at the beginning they will be confused with the RD, RT, and also they cannot match the principle to our configurations. And in the configuration example here, I would list all the examples of Cisco, Juniper, and Huawei. So I will list the configurations of these 3 vendors from 3 vendors, and but like a basic configuration. So hope you can match the principles to the configuration. And the second part, after the configuration example, and Nuru will do a demo of this part, and then we will explain the Layer 3 VPN services, how to deploy. Okay, so first the Layer 3 VPN principle. For MPLS has been used very widely for recent more than nearly 15 years, and for the function, his services, the main services is the VPN. So for MPLS, we can deploy the virtual private network, and can be used because of the labels can be there would be layered of the labels, so different layers of labels can be used. So we can deploy the Layer 2 VPN and the Layer 3 VPN. So the major differences between the Layer 2 and the Layer 3 VPN is depends on whether your customer they want you to, for example, if you are the ISP and the customer connected with you using the Layer 2 VPN or Layer 3 VPN, Layer 2 or Layer 3. If they are using the Layer 3 VPN, so for ISP, your provider edge routers, PE routers, they need to maintain the IP routing table for the customers. And for Layer 2 VPN, you can imagine this is Layer 2. So for our customers, ISP's customers will connect into our ISP, just like connecting to a Layer 2 link layer. And so for our PE routers inside the ISP, they don't need to maintain the IP routing information for our customers. And for Layer 2 VPN, there are 2 types. One is the point-to-point, and also called the VPWS, Virtual Private Wire Service. And also the other one is for the multi-point, like a switch. Okay, so virtual private LAN service. So VPLS is only used for the Ethernet interfaces, and the VPWS can be used for the ATM and the POS and all different Layer 2 link layer protocols. Okay, so our key point for this session is about the MPLS Layer 3 VPN. Layer 3 VPN. So I mentioned Layer 3 because the PE routers, they need to maintain the IP routing table for the customers. And here sometimes we also name that one as the BGP MPLS IP VPN, because BGP is very important. Is very important for this part, and later we can see how BGP is used. And this is for Layer 3. Of course, for VPWS and the VPLS, for the compiler technology, BGP are also used here. Okay, so our key point is the Layer 3 VPN. So layer 3 VPN, these are the advantages, and obviously this has been used in so many networks and used for so many years. And for the scalability, if you have another site need to create a VPN, and then you can configure on the P and then connect our CE, our customer network inside. This on this provider edge router, you just set up the BGP session, and then he can learn all the routes for this company. And the security. Okay, because in the public network, we will have 2 layers of labels. MPLS, we are using label switching. And easy to create on the P routers, so later you can see for layer 3 VPN, because P routers, they need to maintain an IP routing table for our customers. So the P routers are very important. And all these VPN configurations on our P routers. And the flexible addressing. So because we can use for the virtual private network labels, different layers of labels. And the customer's IP addresses are hidden inside, and so we are stored in the VRF table. So we can use the private IP address for our customers, and different customers, they are totally separated, isolated to each other, so they can use the same range. And later you can see why do we need RD and RT related to, so we can realize the flexible addressing. And the QoS can be supported because inside the MPLS label, there are 3 bits for the traffic class. So we can mark the same for IP. You have the traffic class information. DSCP can be also mapped into the QoS 3 bits traffic class. And the straightforward migration, that is for the migration from ATM to the MPLS network. And I think nowadays this scenario is much less. Okay, these are the advantages why we need the MPLS layer 3 VPN. Now we start to talk about the topology. So maybe before, in the previous part, I already mentioned a lot of the PE, P routers, and CE routers. So here, this is the definition. What are PE and P routers and the CE routers? So here is a basic topology of the MPLS layer 3 VPN. In fact, layer 2 VPN is a similar topology. And in the middle part, in this cloud, these are our ISP's network. Okay, so, and inside the ISP's network, there are 2 types. In the middle parts, we call them the P routers. Normally in the core parts, And for the edge parts, we call them the provider edge router, PE. P router. PE routers will be used to connect to our customer. So maybe your customer, for example, if you are connecting to different, okay, maybe this is a bank, and this is the other organization. They want to be separated, and via using the layer 3 VPN. So the customer inside the network, and there are also some edge routers. We call them CE. CE will be connected to the PE router. Okay, here is connecting. So CE is directly connected to the PE router. And later you can see we will discuss how the routing information sent from CE to PE and PE sent to the other side of PE and communicate. And in this topology, we can also see layer 3 VPN is used to connect different branches of one company, and they can talk with each other, and they consider they are connecting with each other directly. So, for example, VPNA, if VPNA is one branch of one company, of company A, and so here is the, maybe we can suppose this is another branch for company A, and they are, both of them, they are, in fact, they are in different locations. They are in different locations. So maybe one is in, here we are in Vietnam. So one is in Ho Chi Minh City, and the other one is in Hanoi. Okay, so inside in the middle is the ISP's network. And okay, so here for his office in Ho Chi Minh City, we're connected to the PE routers in the pop of the Ho Chi Minh City. And for the ISP, they have a large network. They are connecting to the different sites, different cities in Vietnam. And then our office for the company A will be connected to the POP routers, the PE routers inside in Hanoi. So here through the ISP network, these two companies, these two branches, they can talk to each other. They think they are directly connecting to each other because inside in the ISP network, he will create the VRF, create a VPN for this company, and they would only receive the routes. So maybe you consider, oh, he is connecting to the ISP. Maybe this ISP will send all the routes to him. All the routes, that means the internet routes and his own infrastructure routes and also the other company's routes. No, because here is we are talking about the VPN, virtual private network. So you are totally isolated with the other companies. And for this PE router, he would only send the routes related to your company. So we will have the VPN information here and for company A, and also VPN information here for company A. And so only when you have the company A information, you will send it to this PE router. PE router will send it to them. He will not send the company B's information to them. So how can we realize this situation? This is also only related to the routing information and for the control plane. Maybe you will consider, how can he know? Should only send it to this PE router. So we are using the labels. The MPLS 2 layers of labels are used for the layer 3 VPN transporter in the core network. Labels are only used in these core paths. Okay, later in the configuration, I hope you can also see MPLS is only enabled inside the ISP. So for you, if you are the customer of the ISP, you are connecting to the ISP, you don't need to run the MPLS. So our CE routers, only IP, you only need to support IP. Okay, so for our ISP, we need to support MPLS. Okay, so now we need to talk about the principle. So how can we realize from the one CE to the other CE inside the same company, they can talk to each other, same kind of, they directly connected to each other and will not be mixed with the other companies. And even they are using, maybe they are using the same IP address. Why do I mention that? Because nowadays in most of the many companies, they are using a private IP address because the public IPv4 addresses are not enough. So you are using the private IP, but you are totally separated. You are using 10.0.0 and he is also using that one. But the PE router can separate them. So how can the PE router separate them? I would explain in the following slides. Okay, first one, how can PE separate them? So basically, we would introduce on the PE routers. So we will talk about from the left side to the right side. So on the PE routers, we will create the VRF. So virtual routing forwarding table for different company, we will create a different VRF. So here for company A, we will create one VRF A, and for company B, we will create a VRF B. So all the company A related routing information will be put into the VRF A, and all the routing information related to VPN to company B will be put into the VRF B. So they are connected directly. And so VRF A and the VRF B, they are totally separated. So we have one IP routing table for the VRF A. We have another IP routing table for VRF B. When you check the results, you will show VRF A, show VRF B, and also you have another IP routing table for the public network. So they are not in the public network. They are in the individual network. So you can imagine, sometimes we can also say this is the virtual router. We have one virtual router connected to the one company, another virtual router connected to another company. Okay, and then maybe you'll say, how can we, for this router, how can he know I should put the routes into this VRFA? Because we would physically put this interface, not physically, in the configuration, I mean really in the configuration, you will put this interface into the VIF, put this into interface into a VIF. So that means, okay, any routes I received from this interface, I will put into a VIFA. So this is the routing information, control plane, routing information. How can we send it from the VPNA and to the right side? Okay, VIFA and then VPNA, any route 10.0.0 and will be put into the VIFA routing table, and 10.what and put it into IP routing table, because we put this interface into the VIF. So in Huawei configuration is the IP binding. So we bind this interface into the VIF. So for our customer, you don't need to worry. You only configure the normal information, configure interface here and the PE router. This one is the PE router. He will put the information, the routing information into the VIFA routing table. Okay, so first we have introduced the VIF, and then we put the interface bind into the VIFA routing table. And okay, so how the routes transfer from CE to PE? How can we realize this one? They will use so first is about I mentioned the global routing table is here. The individual one we will learn from the public paths. And here we can see all the PE routers connected to P routers, and PE routers. And then we will configure OSPF, and then we will generate the IP routing table. So this is the public part, as normally you do before you create any VPN information. This is the global routing table. So when you check, okay, from one PE router, can I ping to the P router or PE routers, you will check the global routing table. So for then here, this step, you need to distinguish. There are different routing tables. This is the global one. And then for the VIF routing table, I mentioned, okay, we can put them inside. And what protocols can be used? We can use from CE to PE. CE to PE is a very normal one. So it's up to your customer. Okay, which protocol you want to connect with me? Okay, you can use static. You can use RIP, BGP, OSPF, ISIS. Different protocols can be used to connect from CE to PE. Can I ask you which protocol are you using for your network from CE to PE? BGP. Okay. Okay. Okay, so all are used in your network. Oh, okay, I see. So here, maybe you are using BGP, so eBGP will be used. Yeah, eBGP. And one AS, and here is another AS. And okay, and for our CE router, later you can see the configuration. The configuration is very easy for CE, just the normal in the BGP and then peering to this one. And the eBGP normally will appear using the directly connected interface. Yeah. And for this side, I didn't put the configuration example from PE to CE here, but we need to know if you are using BGP, then you need to go to the BGP IPv4 VPN instance. If this is IPv4, you need to go to IPv4 VPN instance or VRF, and then to create the neighbor from PE to CE. So later you can see that is another view, and from PE to CE via using BGP. If you are using OSPF, okay, so if you are using OSPF, can you use the same instance here? If you are using OSPF, isn't there any special part? How many processes are running? How many processes is ISIS? Okay. So your core network is running ISIS, and then from PE to CE, maybe because of the customer, and then you are running OSPF. Oh, okay. Yeah. This is if not so many routes, we can put the static routes and then put into. Oh, okay. Okay. So did you run LDP here? LDP. Oh, okay. Yeah, yeah. I saw these cases in Pakistan before. Yeah. Mm. Oh, yeah, 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 yeah. This is what I say. I think this is yeah. Yeah, 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 yeah. That's true. Okay, okay. I see. Yeah, yeah, yeah. I know what you mean. Okay. Yeah. Oh, okay. Static routes. Mm. Under the control. Mm. Yeah, yeah. Good. Mm. Yes. Mm. Okay. Okay. I see. And later I have the configuration example is using eBGP one. Oh yeah, I will have the example one. Okay, so here we can use different protocols, so it doesn't matter. And what I mentioned about the process one is that if here you are running ISIS and if you are running OSPF, okay, I suppose if you are running OSPF here, and if you want to use OSPF talk from PE to CE, the nano process, yeah, same for ISI. So that process will be related to VRF, yeah, VPN instance. Hmm. Yeah, 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 yeah. So, his process related to this one should be under the VRF, yeah, with the so for. Yes, yes, good, good. Yes. In redistribute. Yeah, in BGP. Yeah, in BGP that is related to VPN instance one. You need to go to the BGP VPN instance one and then import in. Yeah, yeah, yes. Yes. Good. So here from CE to PE is clear, and then for the MP-BGP. MP-BGP, then we continue. After from CE to PE, then we will talk from PE to the other PE for the control plane. How can we send the routes? And for this part, we will talk about RD, RT, and the VPN label. So BGP, basically, he cannot support this, so we have extended some features. RD is used to change the IP address to be the VPN v4. And RT is used to control which VRF will receive the routes. And then the other one is the label, because we will use 2 layers of labels. And the BGP will distribute one label. BGP will distribute one. And here, the BGP has been extended to be the MP-BGP. Okay, so here I will talk about the RD. First, RD. RD, his function is like this. He is not an attribute for BGP. He is used to change our IPv4 address to be a VPN v4 address. Because for some VPN, maybe different companies, but they are using the same block of the IP address. So maybe all are using 10.111 and 10.111. So how can we distinguish them? When PE, maybe on PE it's okay. There are different VRF, different VPN instance routing table. But when you send out using BGP, BGP needs to distinguish them. So we can use the RD. So for different VRF, okay, company A, I configure one RD. Company B, you configure another RD. And so here, this is the format of RD, 8 bytes. 8 bytes, 2 bytes are for the types, and there are 3 types. And for type 0 is the common one. We are configuring 2 byte AS number and then 4 byte for the other code. You can configure as you want to identify the customer. And type 1 is the one with the 4 byte, like the IPv4 address, and then 2 bytes, like a code to identify. And then the other one here you can see 65538. I intended to use this number because this is represented like the 4 byte AS number. It's larger than 6553635. So this will be 4 byte AS number with 2-byte code. 2-byte code. So here is for the VPNv4 address, and combined with the IPv4 information. So for some company, different company, they will use different methods. Some company are using the AS number, so maybe the 2-byte AS number and with the code. This is one format. And some company are using the 4-byte number, 4-byte IPv4 address. So here, he is using his own AS number. And some are using the loopback IP address of the PE to identify. And I test for some vendors routers, maybe they only support the first 2 types in the BGP configurations. So, and some new versions, then they can support this one because this is a 4-byte AS number. How about your AS number? Is 4-byte or 2-byte AS number? 2-byte AS number. And I think you are using the type 0, yes? Yeah, with the AS number and the code. This is common. Yeah, RD. Okay. This is your RD. Okay. Yeah. So different. Yeah. Because we need to extend. We should have this one because the AS number. Some company the AS number they apply new AS number is 4-byte AS number. So they will use this one. Yeah. So but if your router cannot support, maybe you can use other number to represent. If you can use other, maybe not really the AS number. So here is RD. We need to remember RD is only used to change this IPv4 address to be VPNv4. Okay, so here VPNv4. Don't forget this one because some new learners they say, where is VPNv4? Suddenly jump out to BGP VPNv4 view, and then they don't know where. Why do we need to go to VPNv4? Because here we change the IP address to be the VPNv4 IP address, and here is the format. And RD is only used locally to distinguish. So look on this PE router, the RD should be different for different VRF, and with the other PE router, it doesn't matter, will not affect. But on your own router, they should be different. So here is the definition of RD. Locally, and then advertise the route. You can see, so here, the routes from the company A and the company B, they are both using the 10110, 10110, and connecting to our PE router, for example, in Ho Chi Minh City. Connected here. So we have created the 2 VRF A and B, RD 100 to 1, 200 to 1, different, they are different. And then for the VPNv4 prefix, later you can check the VPNv4 prefix. And but for different vendors, maybe the results are different, but the format, okay, is with this is the VPNv4 prefix. RD plus the IPv4 address. RD plus the IPv4 address. Okay, so these addresses will be advertised to the other side PE router and carried in BGP updates. Okay, so this is our VPNv4 prefix and carried in our BGP updates from one PE to the other PE. VPNv4. That is RD, and then another one, RT route target. Route target, this one, the formats are the same, totally the same as the RD. So some companies maybe they configure similar format and the same AS number and related to different codes, and for the different VPN instance. And RT is function. Basically, this is a extended community attribute. So he is included inside the BGP updates as an attribute. What are the attributes? For example, we have the attributes of the origin and the AS path, next hop, local preference, MED. These are attributes. And for the route target, he is another type of the attribute. So we carried the RT as the attribute to configure. But you can see, in previous one, RD, for one VRF, we only configure one RD. But for RT, it's different. At least we have two types, export RD and import RT. And you can only configure one. It's up to your requirements. But normally, if for a full mesh connection, we will configure both export RT and import RT. And for RT, you can have multiple numbers. So maybe you have 3 numbers of the export RT, 100 to 1, 100 to 2, 100 to 3. And the import RT, you can configure different values, and maybe 1 or 2, and how many is up to you. So for RT, we have 2 RT. Later I will explain the different functions. And also, we can configure multiple values, because RT can help us to realize the very flexible topology for the VPN layer 3 VPN topology. Okay, so this is RT. And here, let's see what is the function of RT. So here I have list using an example for the PE1 or PE2. You can see what are the import RT, export RT, import RT, export RT for different VRF, VRF-A and VRF-B. So here you can see for VRF-A and VRF-B, we have the different RD has been designed. If we have announced the prefix, from the PE1. Okay, I have received some routes from VPN-B, and the VPN-B, his CE will announce the prefix 10110 to PE1. And then when PE1, he wants to announce the prefix to PE2. First operation, he will add the RD in front of the IPv4 address. So this is our VPN-v4 address. And from PE1 to PE2, here is inside one AS. We call this is the eBGP and the MP-BGP, because we will announce the VPN-v4 routes to the other side. So this is the VPN-v4 route we want to announce. So when you announce the prefix from PE1 to PE2, I have 2 VRF. So I should store this route into which one? How can we know? This is through the RT. So route target. Where is my target? So here, maybe you say import, export RT. What are the different functions? It will be used here. So when PE1, you have configured, okay, so you have configured the values on the PE1, VRF-A, RD, blah, 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 RT, 100 to 1 import and 100 to 1 export. And for VRF-B import, there are 2 values, 100 to 100, 100 to 200, and export also two values you have configured. And then we will announce this prefix to the other side PE. We will add the RT, export RT. Okay, here is the function, export RT. Both of them will be carried in the BGP update. This is attribute. This is attribute. Okay, 2 of them are carried. So when this route reached PE2, PE2 will make the decision. How to make the decision? Compare the RT with our import RT. So I will compare, because he has 2 values, and compare whether maybe only one value matched with any of them. We can accept. So you can see here 100, 100, 100, 200. Nothing is matched with the import RT in VRF-A, so we cannot put into VRF-A. And we will compare with VRF-B. Import RT is 100 to 100, so we will compare. Okay, one number is matched. Then we can put this route into VRF-B. So here is the function of RT, and how to use the import and export RT. Is this part clear? Any question? No. So only one is enough. Yeah, only one value is enough. So what is the format in your network? Full mesh. So for example, one company uses the same import or export.
Yeah, most of the time one, but certain cases, because we are using a number of VPN, CI, likewise for different services we are
Oh
using.
yeah. I mean for the call network, different connections.
Sometimes we need to import
Maybe more multiple signals.
multiple VRF routes into the same VRF.
Oh yeah. Then RT can be used. That can design different. Yeah.
Most of the time, one-to-one.
Oh okay. Yeah. Okay, I see. So then RT, you can say, as you said, RT can be used to build up the full mesh and also the hub spoke and also multiple situations. So for example, if for the different size of your company, they want to talk to each other. So we call this is the full mesh. They can directly talk to each other. So they need to learn the routes from each other directly. So here, these are the sites. How can we design the RT? We can configure all these sites. They are using the same import and export RT. You can see from the import RT, if from this site to this site, if his export is 100 to 10, same, when we announce the routes to the other sites, we will put the export RT 100 to 10 into the route, and to reach this site, we will compare his export 100 to 10 compare with his import 100 to 10. They are the same, so we can put the routes into this site, same to all the other two sites, so they can form the full mesh. Is this the one in your network? The same.
We are using to import.
Oh yeah. So here he can import from the other. Yeah. So here is a hub spoke. I think for your case is the other one is using more flexible. Yeah, can be used to import the routes. So hub spoke is also like some common scenario used. So hub spoke, you can see for this branch size, we don't want them to talk to each other directly. So we want if you can talk to each other, but all your traffic should go through the hub size. So how can we realize that? So that means the routes he announced to him. Maybe you consider how can he announce to them? Because the PE routers, they are full meshed connected with each other. Maybe you are using the route reflector. They can receive all the routes, but we will compare the RT. You can see his export RT is 100 to 11. And when the routes reached on this PE, his import is 100 to 12. They are not matched, so he cannot be received on the spoke, but it can be received on the hub size. So here is the hub spoke connection. Okay, so here is the function of RT, and it can be used to make more flexible connection, the topology. Yeah. So if for your case, for example, they are using different export, so 100 to 10, 100 to 11, 100 to 12, he can use the import 10, 11, 12, or in this part. So all the routes can be received from here. Okay. And then for the label control plane, we will announce I mentioned RD VPN v4 routes, RT the attribute to be used to decide which VRF I will put this route, and another one label, the private label will be used. You can see here. So when BGP announces this prefix to the other side, he will distribute a label for this route. He will distribute a label 100. So for your case, you are using a TE for the out label. So that label is distributed by RSVP, but the inner label, the inside label is distributed by MP-BGP. Yeah. So BGP is used to distribute a local label. So sometimes if you do the troubleshooting, where is the inside label, should check the BGP. Yeah, check the BGP. Okay, so here is for the local label and the RT, and send it to the other side. So the label is sent from the downstream to upstream. So he generates a label. and then the other side will store this label. Okay, he will put this one. Okay, if I want to send the traffic to this VIF and the 10110 block, and then I will first attach one label, 100, and then we'll send the route. Or we'll send the traffic. This is for the forwarding path. So here you can see these are the three basic operations for the PE when he send the routes to the other side. Okay, add the RT, and add a distributor local label. And another one, he will change the next hop to be himself. Okay, change the next hop. When he send the routes to PE2, he will change the next hop to be himself. Normally, they are using a loopback address to set up the BGP neighbor. Okay, so the next hop will be changed to the IP address the IP address which is used to set up the BGP neighbor with the PE2. So normally it's the loopback address. So these are the 4 operations and send it to the other side. Okay, so for PE we have done these operations. Okay, I can go through we have a walkthrough of the control plane. You can see. Okay, first the CE will send announce the prefix 10110 to PE1. CE1 send it to PE1, and the next hop is CE1. Is this interface. Okay, maybe you are using OSPF or static routes, but if static routes we don't need to announce. You configure it on PE1. Yeah, and then PE1. Okay, he will convert it to VPN v4. We will put the RD in front of this route, change it to be VPN v4 route, change it to VPN v4, and then we will add the RT, export RT. So okay, I mentioned that 4 operations, and the VPN v4 add the RT and change the next hop to be himself. Next hop is also an attribute to be himself and assign a label 100. Okay, so here, these are the operations, RD plus the IP address, and change the next hop to be himself. Normally, it's a loopback address. We will set up a loopback address with the PE2, and RT 100 to 100, and label 100 will be assigned the out label. He will assign it to this one, and he will store as he will store this one. Oh, this is the incoming label. Here is the out label. When he sends the VPN traffic, he will add the label 100. Okay, MP-BGP update. And then on PE2, he will check the RT. Okay, I will check the RT. You can see on the remote side, we will not check RD. RD is only effect locally to distinguish different routes for different VPN. So for PE2, we will compare RT and then put the routes into the right VIF, and then send the routes to the VPN sites. Because here, this interface is also bind under this VIF, So these are the whole control plane process for the VPN routes. Okay, so is there any question here? Yeah. Thank you. And then the label, VPN label, has been advertised from here. But you can see when P2 router, he said, okay, I want to send the traffic to this destination, 10110. Okay, you can use the out label 100. Out label is 100. But, okay, I can add the out label. But the next hop is PE1. So he should send this packet to reach PE1. The out label is on 100. But the packets will go hop by hop. But when the packets come to this P router, if only with the label 100, what do you think the P router will recognize this label? No, he cannot know. So this VPN label should be analyzed by the PE1. So how can we pass the packet from PE2 to PE1 with keeping the VPN label? Because we are using a label for forwarding. So here, based on the router, he is already using label forwarding. So he will search the LSP for PE1. for PE1. How can we send the traffic from PE2 to PE1? And this part, so we were in the public network. So some network will configure LDP. In many networks, they are configuring LDP. So that's why we need to configure LDP in the public network. And as in your network, you are using TE. Yes, using the MPLS TE. So for your network, you directly set up the channel from PE2 to PE1. And then using the label swapping here to the PE1. And if you are using LDP, okay, so we will set up the neighbors between each router. In all the MPLS domain, we will run LDP. And here is the label forwarding table. Label forwarding table if for the LDP. Okay, so PE2, because based on the IP routing table, based on IGP, we are running OSPF, maybe ISIS in the core parts. After we set up the IP routing table, based on the IP routing table, then we will run LDP. LDP will generate based on the IP routing table to generate the label forwarding information base. Label forwarding table. Okay, so PE2 will know, okay, next hop is 1111. So how can I go to 1111? Out label is 25. So here is the label forwarding information for 1111. That's why I put the prefix 1111 here. Okay, so in the public parts, maybe you are using LDP, maybe you are using RSVPTE. Yeah, this is for the out label. Okay, we can also call this is the tunnel label. And these are about the control plane. Okay, so for the data plane, okay, I will simulate. After we have set up the 2 layers of labels, then we will send the traffic from the one side CE to the other side CE based on the labels we have got. So here, PE1, CE2 will send the IP packet to PE2. Here, no MPLS between CE to PE. And on PE2, we need to add 2 layers of label. One is for the destination, for the VPN. So 100, we store this one. And the other one, 25, is going to 1111. 25 is going to 1111. Okay, when P2 router, he has received, he would know, okay, I need to swap 25 to be 50, go to P1. And P1 will go to the PE1. On PE1, he would know incoming label is 100. He would know, okay, this 100 is what I have assigned for this VPN routes, and then send the traffic to this VPN interface. Okay, so send the normal IP packet. So here we can see we send out we have pop out the 50 is the penultimate hop. Okay, with 1 layer of label. And VPN, that means for the public parts, all are using the same LDP. So for example, here, this LDP path can be used for multiple VPN instances. So if you are creating one channel, for example, from PE2 to PE1 for TE channel, and this channel can be used for different VRF, yes. Did you configure for one VRF, only used for example, one channel is only used for one VPN instance?
TE tunnel.
Oh, okay.
As you can see, we have only one tunnel.
Oh, okay. One. So from one PE to another PE is only one tunnel.
Yeah, only one tunnel.
Oh, okay. So, but you have defined the path.
Yes.
Yeah. Okay. Is there any policy, VPN tunnel policy? Oh, okay. So here is using a static route. Yeah. Oh, yeah. OSPF also sometimes. Oh, okay.
Only one tunnel for one destination. Then you could pick this another room.
Oh, okay. Here. Yeah. I know. I say using the reserved for binding. Yeah. this command means use the for the VPN reserved for binding.
Then why RSVP?
Okay, maybe I will come back again. Okay, so here is about the data plane. So is this part clear? Okay, so 2 layers of labels. So this outer label can be used for different VRF. So that's why we call this is the virtual private network. And the public network, they don't know what is inside. Is for the P routers. Hey, just okay, I swap the label, but I don't know what the inside is for company A or company B or company C. I don't know. I only check the outer label. So inside maybe is VPNA traffic, VPN traffic, but they are sharing the same public network. So this is the virtual private network. And here for some configurations. This configuration is using the Cisco commands, and later have Juniper and Huawei. And for the Cisco commands, you can see I'm using a very simple topology. So for the core paths, we have 4 routers, and these are the low-back address 1, 2, 3, 4, and from CE1 is the 100.110, 200.110. Both of them are belonging to the same company, VPNA. Okay, I will run BGP between the CE to PE. I will run BGP. So before we configure the VPN, we need to configure the IP addresses on all these routers. And IGP on PE and P routers, you need to run OSPF or ISS to make all these routers can access to each other. Okay, and later we can see we want to reach the result is CE1 can communicate with CE2 after the VPN configuration. Okay, and for all the PE and the P routers, you need to enable the MPLS part. For example, and for Cisco routers, if you want to run MPLS, you need to enable IPsec. And okay, so you configure the route ID, MPLS LDP route ID is low-back 0. This is normally very common, everyone is using. And for the interfaces, you can see on PE1, you only need to enable MPLS on this interface, because here we are running IP. So P routers, you need to enable MPLS and forwarding on this. So these links, we are running MPLS using label for forwarding. Okay, so MPLS IP label protocol LDP. So here, if you are using the LDP for public network, you will enable LDP. Otherwise, you can build the TE tunnel if you are using TE. And then continue. So we basically configure LDP. The public path will be okay. And then VRF. So we create the VRF here on PE. Both PE1 and PE2, you need to create the VRF. The name is VPNA. Maybe you can configure for company A or company B. And RD, so here RD, only one RD for one VPN instance. RT, you can configure multiple. And import, export. And here RT, you can configure, but it's up to you. Here I just directly configure the same value for the import and export. I only want them to communicate with each other. And address family IPv4. And then we create the VRF. We have used the RDRT here. Okay, RDRT configured here. For the interface from PE to CE, we need to bind them into the VRF. So in Cisco configuration is a VRF forwarding VPNA. So here is a name, should be matched with here. The VPNA. After you bind the interface, you will configure the IP address. This is from PE to CE. You need to configure this one. And MP-BGP. So we need to configure the MP-BGP from one PE to the other PE. So here is the Neighbour. We need BGP AS number and Neighbour. We using a low-back address. if you are configuring with the route reflector, okay, you can enable with the route reflector. And here for Cisco routers, we need to add this command, send the community both. So because on Cisco routers, by default, he will not send the community. Which community? RT. RT is a community here, so we need to send the community. But for Huawei routers, even for the community path, you need to configure community, but here you don't need to add this command. You don't need to add this command. So for Cisco, you need to add the send the community both. And for the P, next hop self. No, next hop self is related to is for the, if I receive some routes from eBGP routers, I send it to the iBGP, I need to change the next hop to be self. Yeah, here we only need to change the update source loopback 0, connecting interface loopback 0. Yeah.
I think for VRF, it is the VRF next of self is there by default. This router is there by default for VRF, but for global routing needs to be there.
And for the PE to CE, eBGP, and here you can see for the BGP, we need to go to the, because for PE to CE, this example I'm using eBGP from PE to CE. So okay, so BGP previously in VPN v4 address family, okay, VPN v4 address family from P1 to P4. And for the PE to CE, we will go to the IPv4 VRF, VPNA, so another address family, and then you point to the from PE to CE, from PE to CE. And adding the PE to CE on CE, you can see on CE is a normal address family. We don't need to go to any VPN, not related to any VPN. So here is for the CE is very normal, but for PE you need to go to the VRF1. So if for OSPF or ISIS, you all need to go to a VPN instance. Static route, you also need to IP static and some VPN instance. Okay, so here is the configuration. Configuration are basically these steps. And I hope if for some new learners, sometimes they will be confused with the which address family should I configure, which neighbor, and for the other address family from PE to CE, this part should be distinguished. Okay, sometimes at the beginning people will be confused. Why jump out so many address family, and they just peer everything, redistribute everything, but these are with different functions. And then, okay, after the configuration, okay, we need to both sides we need to configure, and then on PE routers we can check the routes. You can see show BGP VPN v4. When you want to check the BGP routes, you also need to go to the maybe VPN v4, and for the VPN instance, you also need to go to VPN instance view. And here are the routes. And the 100.110 is the one I learned from my CE router, and 200.110 I learned from who? You can see 4444. Next hop is 4444. That means this one is from the PE2. Yeah, from the other side of PE. And local preference here, and this is the AS path 65002, the AS number. Okay, here is the RD 100 to 10. Okay. And CE, then CE can learn the routes via BGP. Okay, CE2 200.110, he can learn the 100.110 via BGP. So here they can access to each other. This is for the Cisco configuration. And for Juniper, the same topology, totally the same topology. And here I will go through the commands, okay? And the same, we will configure the MPLS and the LDP. Okay, go to the Cisco Juniper commands are more different. Okay, and so we will go to the interface. Okay, you need to if you are running MPLS and LDP. If you are running LDP protocols, MPLS this interface and LDP this interface, you need to enable MPLS and LDP same on the public network. And VRF instance you can see, and also the name VPNA and the instance type is the VRF, and the interface EM 1.0 you can see EM1.0, 1.0. We put this interface, bind into this VIF, and RD and target RT here. Here is the VPN target, RT, both of them. Okay. Then we will configure MP-BGP on the PE routers. So enable for the BGP AS number, router ID, and then you will configure your local address and the neighbor's address, and the type is internal. Okay, so we need to create, and the family is the iNet VPN. So for the VPN. Okay, and for the PE to CE, here is the external. We are using eBGP from PE to CE and pointer to 65001, and the neighbor is using a directly connected interface. Okay, and then add the CE to PE peer on the CE. So this is for the CE. CE configuration will not relate to VPN, just enable pointer to PE, from CE to PE. Okay, and advertise static route. So here on CE, I would advertise, I just generate a static route to the 100.110, generate a static route and define a policy, and then apply in the eBGP. He will export this prefix to the eBGP neighbor. The configuration is different compared with Cisco and Huawei. Okay, and then we can check the results. Okay, so we can see on the PE routers, these are the prefix. You can see RD has been added on Juniper routers. They have put the RD in front of the route for the VPN v4 routes. Okay, and the VPN routes in BGP, VPN label. Here is the label 30016 AS and the community. You can see different vendors. You can see they put the show different information, and they can make us clear with the AS VPN label. Next hop, so he will change the, you can see receive the next hop has been already changed. We don't need to configure that one. Okay, this is the configuration on Juniper routers, and Juniper routers BGP is 172. Okay, and on CE1 we have learned this route. So our target is make the CE1 to CE2. They can reach each other, can learn the routes from each other. Okay, here is for the Huawei configuration. And basically is the same. MPLS, enable MPLS and LDP. MPLS and MPLS LDP, both of them, and then in the interface, which you need to enable MPLS and LDP. And then for the VIF instance, VPN instance in Huawei, they call them the IP VPN instance, the name, and then go to the address family RD and VPN target, configure the RT VPN target. Okay, and go to the interface. And when you bind any VPN, bind the interface into one VIF, all the configurations will be deleted. So you need to, and then after that, you configure the IP address. This is on from PE to CE, the interface. And for the MP-BGP, okay, here 4444 and the connector interface, loopback 0, and then peer enable. So here we don't need to configure send the community, that one, export the community. So there are some differences. So by default, that can only see on Huawei routers. By default, he will send the RT to the other side. And also by default, he will change the next hop to be himself. Yeah, this is for the MP-BGP. Okay, so from P to C, we will add inside the VPN instance. Okay, we'll add from P to C in the neighbor. On CE is a very normal one. We just create a static route here, non-zero, and then put this route network in BGP. And okay, then we can check the results. Display BGP VPN v4, and then we can see for both sides we have received. So you need to identify the VPN instance, or maybe VPN v4, and then he will tell different instance. Okay, and then on P1 we can also check the label. For the BGP, what is the label 1028? 1028. I didn't show the LDP label path. I didn't show them here. Okay, so here we can display IP routing table from on the CE, learned via eBGP. Okay, they can reach each other. So here, these are the configuration example for the layer 3 VPN. Any questions here? Because it's already after 12:20, so I think this session will be done here. And maybe I can have a look of your configuration. Yeah. Okay. Jordan, okay.